For nearly 90 years, the world has believed we understood how this story ended. A legendary pilot, a tiny island, a missed landing, a tragic crash. Case closed, at least in theory. But what if the final chapter of Amelia Earhart's life was written somewhere else entirely? What if the island we've focused on for decades was never part of the ending at all? Tonight, we examine a 2026 breakthrough that challenges the Gardner Island narrative and shifts the crash zone hundreds of miles east into one of the deepest, most unforgiving stretches of the Pacific Ocean. And if this theory is correct, we've been searching in the wrong place since 1937. July 2nd, 1937. Earhart and her navigator, Fred Noonan, were nearing the most dangerous leg of their round-the-world attempt. Their aircraft, a gleaming Lockheed Model 10 Electra, had already crossed continents and oceans. Now they faced the most daunting challenge of all: finding Howland Island, a speck of land in a vast, empty ocean, 2.5 miles long, barely visible even in perfect weather. Cloud banks formed that morning, visibility shifted. Navigation depended on celestial calculations and dead reckoning, methods that allowed no margin for error. At 7:42 a.m., radio contact crackled to life. "We must be on you but cannot see you." The Coast Guard cutter USC GC Itasca listened anxiously. Earhart's voice was tense but controlled. Minutes later, another message: "We are running north and south." Then, silence. No confirmed transmissions, no confirmed sighting, no wreckage. The largest air and sea search in U.S. history at the time swept thousands of square miles. Nothing. Eventually, investigators concluded the aircraft likely ran out of fuel and ditched near Howland Island. Years later, attention shifted to Nikumaroro, formerly Gardner Island, roughly 350 miles southeast of Howland. Artifacts found there fueled decades of speculation. The Gardner Island theory became dominant. But science doesn't stop evolving, and in 2026, the Pacific started whispering something different. In the days after Earhart vanished, radio operators across the Pacific reported hearing signals. Some came from commercial ships, others from amateur radio enthusiasts, some even from the continental United States. Most were dismissed. Why? Because signal bearings didn't align cleanly, because hoaxes were common, because atmospheric interference distorted reception. But in 1937, radio triangulation was crude, solar activity wasn't fully understood, ionospheric bounce effects were unpredictable. In 2026, researchers digitized every surviving transmission log. Then they did something revolutionary. They reconstructed the ionosphere of July 1937. Using archived solar flare data, atmospheric modeling, and AI-assisted signal simulation, analysts recreated how radio waves would have traveled during those exact nights. The results were shocking. Many of the strongest credible signals could not have originated from Nikumaroro. The signal strength and bounce angles pointed east, not slightly east, significantly east. If those transmissions were real and several matched Earhart's known frequency, then the aircraft had to be somewhere else, somewhere with enough power remaining to transmit, somewhere not yet submerged, somewhere not previously searched thoroughly. And that realization changed everything. Let's consider the flight path. When Earhart said, "We are running north and south," she was likely following a line of position, a navigational technique based on celestial observation. If Howland Island was invisible, she would have flown along that calculated line, hoping to intercept it. But here's the critical detail. Even a small navigational miscalculation, 1 or 2 degrees, could shift the search line hundreds of miles over open ocean. Cloud interference that morning may have disrupted Noonan's celestial reading. Fuel stress may have pressured decision-making, and strong crosswinds, underestimated at the time, may have pushed the aircraft gradually eastward. Not dramatically, not suddenly, but steadily. Over hours, that drift compounds. By the time fuel was critically low, the Electra may have been nowhere near Gardner Island. Instead, it may have been over open ocean, in a zone never heavily searched in 1937. This is where modern science delivers its strongest argument. In 2026, oceanographers ran high-resolution drift simulations using historical wind data, equatorial current reconstruction, and seasonal Pacific climate models from 1937. They asked a simple question: if debris entered the ocean near Nikumaroro, where would it go? Then they asked, if debris entered the ocean several hundred miles east of Howland, where would it go? The second simulation aligned far more closely with later debris discoveries across remote Pacific atolls. Equatorial countercurrents, trade winds, surface push, subsurface gyres. Instead of moving west towards searched areas, debris from the eastern zone would migrate slowly southeast into regions virtually untouched in 1937. Even more compelling, the Eastern crash model explained why no floating wreckage was ever confirmed near Howland. The ocean currents simply wouldn't have carried it there. In other words, search crews were looking where logic pointed in 1937, but physics suggests logic was wrong. So where exactly does the 2026 model point? A remote corridor of ocean east-southeast of Howland Island, between established shipping lanes, beyond the primary 1937 search grid. Depth estimates in this region exceed 15,000 feet. That's nearly 3 miles down. If Earhart attempted a controlled water landing, the Electra could have remained partially buoyant for a short period, long enough for intermittent radio transmission during low swell cycles. But aluminum fuselages are not ships. Saltwater corrodes wiring, engines flood, electrical systems fail. Within hours, perhaps less, the aircraft would have slipped beneath the surface, down into darkness. No reef to catch it, no island to strand survivors, no debris field in shallow water, just a rapid descent into the abyss. At that depth, in 1937, recovery was impossible. Even today, deep-sea mapping in that corridor remains incomplete. The Gardner Island theory gained traction because it offered something powerful: hope. An island meant the possibility of survival, castaway narratives, human endurance. Artifacts found on Nikumaroro, fragments of aluminum, anecdotal bone analysis fueled decades of investigation, but none were definitive. No confirmed serial numbers, no confirmed aircraft debris, no indisputable DNA. The Eastern Pacific theory removes romance from the story. It replaces survival speculation with brutal probability. A controlled ditching, a brief struggle, a rapid sinking. It's colder, but it may be cleaner. And sometimes the simplest explanation, guided by physics, not possibility, is the hardest to accept. The most exciting implication of the 2026 theory isn't just narrative clarity, it's search precision. Instead of scanning thousands of speculative miles, researchers have identified a definable crash corridor. Modern technology changes the equation. Autonomous underwater vehicles, AI-guided sonar scanning, high-resolution seabed mapping, deep submersible drones capable of descending beyond 16,000 feet. If the Electra lies intact on the ocean floor, even partially buried, metallic signature detection could identify it. And if it's found, the mystery that has gripped the world for nearly a century would finally reach a definitive conclusion. If this Eastern Pacific theory is confirmed, it reshapes the narrative entirely. Earhart didn't reach an island. She didn't survive for weeks. She didn't leave coded messages from shore. She fought deteriorating navigation. She exhausted her fuel. She attempted a controlled water landing, and she was claimed by the sea. Tragic, sudden, unforgiving, but also consistent with aviation realities of 1937. Yet here's the truth. Even if the ocean holds her forever, Amelia Earhart's impact remains untouchable. She wasn't chasing fame alone. She was pushing boundaries in an era when women were told flight, literal and metaphorical, wasn't theirs to claim. Her disappearance amplified her legend. And maybe that's why we still search, because this isn't just about metal and coordinates. It's about humanity's refusal to let boldness vanish without answers. For decades, we believed the story ended on Gardner Island, but in 2026, the Pacific tells a different story. A story shaped by solar flares, by shifting currents, by degrees of navigation error, by physics that never cared about legend. If we've been looking in the wrong place all along, then the greatest aviation mystery in history isn't unsolved. It's simply misplaced. In somewhere 3 miles beneath the Pacific, the answer may already be waiting.